Right, so if you've reached this far in the labs, yay. This is the second to last lab sheet, and this is the networking aspect of it. Okay, this is quite complicated, both in terms of installation and configuration later on. So yes, you need to pay a bit of attention to this. So at the moment, if you reach this lab sheet in the labs, you will have one working virtual machine that's running, has an operating system and everything, and it is bridged via BR0 to the outside world, and it has an IP address on network 28 with whatever your IP address is on your computer. So what we're going to do now is we're going to create a bunch of virtual interfaces, network interfaces, which you can allocate to the more virtual machines in your network so that you can connect those virtual machines to the outside world and between them if you need to. Okay, so how do we do all this? First of all, we're going to do a system update. So you need to do a DNF-Y update. So this will update all of the packages on your operating system to their latest versions. Okay, so this is to make sure that you have the latest versions of everything on your system so that you can actually use these latest versions, because they are necessary in order, in the sense of you will need to compile this actual program that will download. So the GCC compilers and the development kernel libraries and everything else that is required for this long process to happen is actually there, and it is at the correct version. So once you do the update should take about 5 minutes, so just let it do its thing. You need to click on this link here in the lab sheet and download a compressed file, a tarball as we call it. So it's a tar.gz, so it's basically a zip file, but in Linux terms. Okay, so you need to download this from this website, and once you do, it will be downloaded in your downloads folder. So you will need to go into your downloads folder and open a terminal in there. You can extract the contents of this compressed file by typing the command tar-x and all the rest of it. Okay, so that will basically create a new folder called OpenVSwitch 2.15 point something, and that will be inside your downloads folder. You will then need to change directory into that folder. This changing directories and opening and extracting files might seem menial to you. However, it's very, very important that everything you do from now on happens inside that folder. Okay, so unless your terminal is open inside the folder, then the following commands will not run. Okay, so the yum -y install commands will run, but then all of the other commands that we need later on will actually not. So once you're in that folder and the software is extracted and everything, we need to install a few prerequisite files like Python, the kernel development files, the RPM config files, the SLinux policy files, and everything else. So you do all of that, and then once you do those 3 lines of yum installs, you also need to DNF config manager set enabled power tools. So you need to enable the power tools, as we call them, in your operating system. So we will need these later on after the installation. Once you do this, you also need to finally install Python 3 Sphinx as well, and this has to happen after the power tools have been enabled. And so once you enable the power tools and you install the Python 3 Sphinx, it's now time to actually build the software that we're going to be using. So we're going to be doing something that we call installation from source, because in Linux you have different ways that you can actually install something. You can yum install it and get it from the internet, or you can basically build it from source, so you can have the source files and you can compile them and create the executable for your operating system. And this is what we're doing here. So there's a boot shell that sets up all of the configuration parameters. There's a configure shell that basically configures all of these parameters ready for the compilation. And then there's a make dist command, which basically makes the distribution. So this compiles the files that you need in order to create the necessary files that we need to create the RPMs in the end. You will need to type this command to create new directories. So this command will actually create folders sources, build, RPMs, SRPMs, and specs. And once you do that, you'll need to type this command, which will basically copy that RGZ file into the sources folder. Once you follow this process, you will then need to build the RPM. So just like before we were installing RPMs from the internet and installing them on the operating system, we will now actually build our own RPM so that we can install it afterwards. One of the most important things that we need to mess around with to do this is we need to tell Open vSwitch how to actually use Python, which version it is, and so on. So you'll need to edit this Red Hat EL Open vSwitch spec file, and you need to go inside this file, and in all of these lines, you need to make sure that it says version 3.6.8, and that it says Python 3 instead of just Python in every single line. Okay, if you miss out even one of them, people usually miss out this last one. Okay, then the very long process that will be the next command will fail towards the end and you have lost about 10 minutes of your life. Great. Okay, so make sure that it says Python 3 everywhere. All right. Once you do this, you can then finally run the RPM build command that will read the Open vSwitch spec file, and it will create the RPM file that will be located into the RPM build folder that you just created. This process usually takes about 7 to 8 minutes to run, and the screen will just scroll endlessly compiling the file. Okay, leave it, don't do anything, just wait for it to finish. Don't do anything else on the system while this is happening as well. Okay, so just let it use all of the CPU that it can in order to run through this laborious process of it. And then once you do this, then you can basically yum local install the RPM that you just created. Okay, so you can actually install the RPM that you just built. Once you do this, it means that Open vSwitch is installed on your system, and you can start configuring it and using it. Okay, so Open vSwitch is one of the different ways that you can do networking in OpenNebula. So instead of using a bridged interface or instead of using IP tables or anything else, we will be using Open vSwitch. It is the most versatile and it is the most configurable out of all of the ways that you can have networking in OpenNebula. In order to use it, systemctl start and systemctl enable will start the service and will enable the service to run every time you start your computer automatically. Once you do this, the first step that you can verify your work is OVS vsctl show. So that should show you the version of OVS that is installed, and that's it. But it should show you something. Okay. This is the first stopping point. So up to this point, if you run this command successfully, it means that you've installed and started the service correctly. Okay, so the software exists on your system and you're good. If you want to be really cautious about this, I would take a backup of your virtual machine at this point. Okay, because things will start getting really messy from there on. Alright, so I recommend you take a backup after this. Because the first thing that you're going to do is mess with your network cards. So that bridge that you had just created, BR0, connecting to ENS 160, that will get changed. Alright, so we will end up with lots of different network cards on your system, and we need to make sure that we can configure them. In order to configure the network cards in the operating system, we need to tell Open vSwitch that these network cards exist and what their names and connection points are. So there are ports and there are bridges. So there are bridges that essentially connect via those ports on the physical and the virtual network cards that we're using. So I'll give you an example. We will create a new bridge and we'll call it VMnet 28. Because obviously this will be working on subnet 28, 148, 197, 28 something. Okay. Now this VMnet 28 bridge will contain a port that's called net28, and then it will also contain another port that's called ENS 160. So essentially, with this network card, we are bridging a new network interface that's called net28, So when you type ifconfig in your operating system, you won't see BR0 anymore, you will see net28 instead, and that connects onto your physical network card that's called ENS160. Okay, so this is the first bridge that we're creating on the system, and this bridge will actually have full internet access because it is actually bridged on subnet 28. So once you do this, you can repeat this command for nets 30, 31, and 32. So we'll end up with 4 working network cards this way, respectively on subnets 28, subnet 30, subnet 31, and subnet 32. So eventually, when you now type OVS vsctl show, this should look something like this. Anything else other than this is wrong. Alright, so you will have your bridges VMnet 30, you have a bridge VMnet 28, you have a bridge VMnet 31, and 32, and that's it. When you do this, you can now tell the operating system that, look, I'm creating new devices, and they're going to be called net28, and they're going to be called BR0, and so on. Okay, and you will need to make changes in the etc. sysconfig network scripts folder. So far, you've gone into that folder and you've changed the ENS160 file in there, so ifcfg ENS160. You've changed that and you've created the BR0, which is the bridge that connects to ENS160, and that's how you get internet to the outside world from your Prometheus and from the virtual machine inside. So we will be changing the files in that folder. So the first thing you need to do is rename your BR0 to net28, because this is just a simple rebranding that we're doing here. Yeah. All of the contents will stay the same, and ENS160 will also stay the same. Okay, and it should look like this. So make sure that you open those files. The safest bet is to basically copy all of the contents of this and paste them into that file and save it. Alright, remember to set the IP addresses correctly and to delete the comments from everywhere. Once you do this, then you need to repeat the process for networks 30, 31, and 32. So you need to create 3 new network cards. So those 3 new network cards will have their configurations inside OVS, so they will show up here. They also need to have their corresponding files in etc. sysconfig network scripts, and they should be ifcfg net30, net31, net32, and they should look like this. There are instructions on here on what IP addresses you should use and everything. So in order to do this, we need to allocate the IP addresses to the network cards according to what scheme we're using in a2.net. Okay, so there is a file in a2.net that's called a2.net subnets, and in fact I will find this and show it to you. And I don't have it in this one because this is a new module, so let's go find it in another one. So let's go to the other cloud computing, the undergrad one, and we can find it here. I will move them in the correct location, don't worry. So networks 30, 31, and 32. How do we make sure that you don't all have IP address conflicts? How do we make sure that you use the correct IP addresses and you don't have overlaps with other people? We take the entire subnet, so let's say subnet 30.0 to 30.255, and we've split it into 64 slices. Okay, those 64 slices will give us 48 slices, one for each of the computers in the lab, and a bunch of spare ones for me to play around with. Okay, the reason why we split it into 64 slices and not into 48 slices is because the IP addresses are really binary addresses, yes? So an IP address, the computer doesn't see it as 148, 197 something. It sees it as bunch of ones and bunch of zeros, 8 bits for each quadrant, yeah? So because of this limitation, because of the way that this works, everything has to be a power of 2, yes? So 0, 1, 2, 4, 8, 16, 32, 64, 128, and so on. Okay, we need to have 48 slices. We cannot have 48 slices. We can either have 32 slices or 64 slices, and obviously we'll choose to use 64 slices. So we've split our network into 64, and then each of the computers in the lab gets allocated a range of addresses that they can use for each of the subnets. Okay, so if you're sitting, for example, in Hunt, then your usable IP addresses are 30.45 and 30.46, 31.45, 32.45, and so on. You also have a network address and a broadcast address because of this. Yes? So you need to have a beginning to your network and an end to your network as they are defined by your network and broadcast addresses. Okay? So this means that in the cloud that you are building, you can have 4 different subnets, 28, 30, 31, and 32, and you can have 2 IP addresses per subnet in there. So you can have 8 IP addresses in total. All right. So that's how we basically allocate the IP addresses, and that's how we set them up here. So if I'm sitting on this, and let's say, for example, I am on computer Hunt, so I'm configuring this network interface, the net 30 on Hunt, then the IP address that I will use here will be the first usable IP address from A to net subnets, and for Hunt, this is going to be 30.45. Okay. Hence why the comments next to these lines. The prefix will always be 30 because this is the subnet mask that we're using for these smaller networks, and this comes from the fact that we've taken this class C subnet and we've split it into 64 slices. Okay, so now the subnet mask will be 30 bits long, so that comes from the fact that our subnet mask is using 8, 16, 24, 30 bits to define our little network. Okay, so each of these slices of that network use 30 bits. So now the subnet mask will change, and it will not be 255, 255, 2540. It will be 255, 255, 255, 252. Okay, this comes from the fact that we've changed this and is simply the binary to decimal conversion of this number here. Okay, so this is 1, 2, 4, 8, 16, 32, 64, 1 to 8. So if you add these guys up, 1 to 8 plus 64 plus 32 plus 16 plus 8 gives you 252. Alright, this is what this adds up to. And we're only left with 2 bits that we can play with our IP addresses, the combinations of which are 00, 01, 10, 11. So that's 4 different combinations. 4 different combinations means 4 addresses for us to play with. So this is the 2 usable IP addresses, our network address and our broadcast address. Okay, so this is how our slices have 4 addresses each, out of which we can use 2 addresses for each of our networks. So going back into this file, subnet mask, and then the gateway. The gateway for this will be the IP address of your Prometheus on subnet 28, because you're going out through your Prometheus VM. Okay, as simple as that. Once you configure net 30, 31, 32, you will get some error message. You usually will get that error message when you try to do the OVS command for subnet 28. So theoretically, usually this is what happens. This comes back with an error. Ignore it. Okay, leave it be in its erroneous state, because once you set up all of these files and you do all of this, you will restart your computer. Okay, reboot Prometheus. Once you reboot Prometheus, that error will go away, because the OVS configuration will see the config files that you've created and vice versa. And then eventually your target is to end up with this ifconfig onto your system. So you will have an ENS 160 that will not have any IP address, and then you will have your fancy network cards, net 28, 30, 31, 32. Okay, Once you've reached this point, it means that you've configured all of your networking on the host with OVS correctly. And if you really want to be pedantic about it, it's a good point to take a backup of your system. Okay, because a lot of configuration to lose if you mess it up from there on. All right, so this means that your host, your Prometheus, is configured correctly. So all of the networking there is done. So then you will need to configure this networking into the cloud itself. So we need to have a way to tell our cloud to use these newly created network cards. The first thing you need to do is you need to go into the networks panel on the left side inside your cloud and delete your existing bridge because that doesn't exist anymore. Okay, before you delete this bridge, it's a good idea to actually remove it from the template of the vPrometheus 0 that you have created because it doesn't exist anymore. Okay, and if you are running your vPrometheus 0 virtual machine in the cloud, if it's instantiated already, you can either kill it or you can go inside it and detach the network card. Okay, so you can remove the network card that is not there anymore, even when the virtual machine is still running, because OpenNebula is flexible in that way. Okay, so make sure that whatever you do, you update that template with the new network interface that's called now Net28 instead of BR0. You go to virtual networks, you follow the instructions here, and you set up the network cards as per the instructions here. Net28 is very simple and it's pretty much exactly the same way as BR0 was configured. So all of the same IP addresses, plus 50, plus 100, the same rules apply. And then you need to create 3 new network cards, that's 30, 31, and 32. And they will be slightly different because of the gateway that you will need to use for this. So remember, at the moment you have set up your network cards, net 30, 31, 32 on the host, on Prometheus, and you've given them the first usable IP address. However, these network cards in here will be the network cards that will be allocated to your virtual machines inside the cloud. So they will need to be the second usable IP addresses. Okay, so you have net 30 on Prometheus. If you are going to have a virtual machine in the cloud that's going to connect to the outside world via net 30, that will need to use the second usable IP address, and the gateway for that virtual machine will be net 30's IP address on Prometheus. So the gateway will be the first usable IP address. All right, and then this is explained here as well. So use your second usable IP address and network address, and then use your first usable IP address for your gateway for this. Once you've configured this, you can create more virtual machines, and the easiest way to do this is to clone your existing virtual machine, so you can duplicate the images and everything else, and you can allocate IP addresses or network cards from those newly created network cards that you have in your system. Okay, this means that you can have now up to 4 virtual machines in the cloud. One of them will be on Net28, so it will be bridged directly to the outside world and it will have native internet access. And you can have 3 more virtual machines that will be bridged onto certain networks 30, 31, and 32. And because they are on different networks, they will not have internet access. Something which is very easily fixable by implementing some routing. Okay. In order to enable routing, you need to do this process on Prometheus. So you need to install something that's called FRR. So you simply do yum install FRR. You need to find the daemons file for that program, and you need to enable OSPF as a routing protocol in there. You'll then need to go to Moodle and find the frr.conf file. So I will have an example of it in there. You need to configure that frr.conf file with the correct network addresses for your networks, and those network addresses can be taken directly from this list in 8.net. Okay. And once you do that, you let the thing through the firewall, you restart it, and you test it by looking at your routing table, and you should be able to see everybody else's routes on the outside world. And at that point, if that works, you should be able to have full internet access in all of your virtual machines now. So this way, your cloud will have been completed. You can have 4 virtual machines, and you can have different networks on all of them, and they can all communicate and reach the outside world. So this way, we have built the infrastructure networking that we wanted, that we were talking about in the very first lecture, which is the networking that connects the virtual machines to the outside world, and if you want to, you can make it connect the virtual machines between them as well. Okay. It is a complicated process, all right? However, you have plenty of time to do this. Okay. So this lab sheet is essentially the last guided lab sheet in this module. The next lab sheet is build me a cloud. So I will give you some specifications for that, but beyond that you are free to do whatever you like. Okay, so this is the last lab sheet that I will give you commands of how to do stuff. Okay, I don't expect anybody to finish this entire lab sheet in 1 week, especially if you take on the routing aspect of it as well. Okay, so this lab sheet should start next week. The week after that is the consolidation week, so we don't have classes. Okay, and then after that we have 3 more weeks before our Easter break. Then we come back, we have 2 more weeks of teaching, and then we have 1 week of assessment. So essentially, let's aim for before the Easter break, you have 4 weeks plus 1 of consolidation, yes? So I would expect you to finish with the Open vSwitch lab sheet at the end of the first week after the consolidation break. So 3 weeks from now. Okay, so I will definitely expect you to be working fully into this for 2 weeks in the lab. All right, so that will give us then 2 more weeks before the Easter break so that we can start dealing with the last lab sheet, and 2 more weeks after the Easter break so that you can finish the last lab sheet. Okay, so 2 sessions for this lab sheet and 4 sessions for the last lab sheet, and that's the 6 remaining lab sessions that we have for the module. Okay, we are essentially halfway through at this point. Okay, very important, make backups of your virtual machines. Okay, and especially if you go into this, make backups halfway through. As I said, there's 2 points to take backups. Okay, because then if we have to repeat all of this and recover all of this, it's just a lot of work. Okay, so you need to be very careful about this. We will have, so next week, the lecture that we'll have next week, I will explain the networking aspect of it much more as well. So some of you might probably have reached this point of starting working on this lab sheet by then. Okay, whether you're in the afternoon group today and you do well, or you're in the morning group next week. So I will go a little bit more into the networking aspect of it. Okay, to make sure that you absolutely understand what IP addresses you should be using, and most importantly, why. All right. And then after that is consolidation week, so there's no lecture and there's no lab and so on. So when we come back after the consolidation week, I will explain the last lab sheet. All right. And then I will have 1 more lecture, which will be further questions and sort of a tutorial for the last lab sheet itself. And then the last week before the Easter break, there will be no lecture. All right, then we'll come back after the Easter break. We'll have a lecture as a catch-up / tutorial to see how far you reached and answer any questions that you might have and so on. And then after that, there will be a revision lecture, which will be the last lecture of the year as well for me. And then after that, we'll have the assessment week, and that's it. Okay, it's all very planned out, but yes. Okay, any questions about this? I know it's a lot of information, but I will explain it again a little bit more next week, and hopefully you will have seen it a bit more by then as well. So your questions will be more specific than what the hell is he talking about now with all of these things. Yeah? So hopefully it will make a bit more sense. Okay. Any questions? All right. Thank you very much.